We're going to continue the exploration of physics joints in Unity, and in this video we're going to look at the wheel joint. Now what I've done is I've taken the scene that we've used previously and I have just sort of expanded it in order to fit a few more things in here, in particular because the wheel joint can often be used for things like vehicles in 2D. It's useful to have some space to sort of have your vehicle move around. The first thing I'm going to do is I added an extra segment to the bridge that we had created before. And in addition, I took the anchors and I removed their colliders. This way things can pass through there. So I can drop, for example, a car on the bridge and then have it move across the platform without interacting with the anchors. But one thing that's useful is that I have all these objects here, and what I'd like to do is create an empty object. And I'm just going to call this object bridge. And the reason I'm doing that is because I want to take these objects and I want to group them under the bridge. So I grab them and I just drag them to the bridge. And then this makes the bridge the parent of these. The reason I use an empty object here is because I don't want any scalings or rotations on this parent object, but it makes it convenient to be able to move that object around. So if I wanted to move the bridge over here to, say, the left side of the screen, I can just grab it by this bridge object instead of having to individually grab these objects. And the other thing that I put in here that I want to make a point of is that you really don't want to have any scalings in here because it's going to affect those child objects. And then the physics on the child objects are going to behave weird, especially if you have weird scaling in some directions. For example, our platforms, if you look at an individual platform, you'll see that it has some weird X and Y scaling in order to make it sort of long and flat instead of being a square. And so the physics behavior you're going to get out of it, if you put child objects under it, is going to be bizarre at best. So this empty object doesn't affect the physics in any way, but it does allow me to move it around. The next thing I want to do is I'm going to take a copy of one of these platforms. So I'm going to move it over here and I'm going to drag it out of the bridge. So I don't want it to be there anymore. And I'm just going to call this cart. And what we're going to do is we're going to build a simple like cart with some wheels on it. So I'm going to take off this distance joint. And now I just have my rigid body with my square collider on it. So what I want to do is add two wheels to it. And if you remember, we had this kinematic ball and a bouncing ball. Well, the easiest thing for me to do, for example, would be to just create a 2D object sprite. And then on that, we're going to pick just our small planet. And we'll use this as a wheel. So I'm going to zoom in here so you can see it. And so we will call this wheel. How about back wheel? And then we can just duplicate this and we will call this front wheel. Now back or front doesn't really matter. I mean, the car has an orientation, so red is the front, and if you had a sprite that actually looks like a car, it would have the same thing. So I'm going to take this, I'm going to move it over somewhere around there and move this just about right there. Now the important thing about the wheel joints is that they're going to have some features to them which we're going to see, but I'm going to do the same thing that I did before, which was I'm going to create an empty object and I'm going to call this car, and I'm going to take my cart and my back wheel and my front wheel and I'm going to drag it to my car. That way if I want to move my car around to different parts in the scene, I can do that and they'll all be together, right? So I can just grab this and I can move it around. And again, if I put my wheels directly underneath my cart, I would have had this weird scaling and it would have caused the wheels to behave weirdly, especially with regards to the sprites and the rotations on those sprites. Now that we have the car set up with the front wheel and back wheel, we need to set up the wheel joints. So we will go ahead and add a component to it. So we will call this wheel joint. And that will automatically add a rigid body to it. Now you'll notice that the anchor for that joint is in a weird place, so I'm going to just drop it right in the center. And the reason is very simple. Like the anchor for the joint should be where the axle would normally be on a wheel, which is often in the center, usually. And the back, we're going to add another component, so we'll add wheel joint also. And again, this adds the rigid body for us. And again, its anchor's in a weird place. Before I adjust that, what I really want to do is put the cart on as the connected rigid body. And this is going to change the location of that anchor. I'll do the same thing for the front wheel. I'm going to grab the cart, drag it over, and this is again going to mess up my positioning for it. So I'm going to go ahead and just set this to 0, 0 so I can locate it quickly and then drag it to the center. So if I zoom in, I should see that the anchor point and the connected point should be in the same location. And this is, again, you know, if you had a better sprite, it would look like the car was passing sort of behind this object so that the sprite was connected where the axle would normally be, but you wouldn't normally see that in a 2D object. In addition, these both need colliders on them. So we will add a circle collider, 2D, and same thing for this one. It was right there. Let's try that again, if I can type. There we go. So now we have a circle collider on both of these. And so you can see the little green outline showing us where it is. I also think that these are a little bit small, so I do want to scale these up a little bit. So maybe make them twice as big. Same thing with this one. This will just make it easier to see, especially when they're rotating on our system. So we have the basic setup. We have the cart set up as the parent, and there's one other setting that's on each of these wheel joints. So if we look at the wheel joint that we added to these, we'll see that there is a dampening ratio. This is the suspension for the object. So it's assuming that your joint is going to have some springiness to it. And at the 90-degree mark, so 90 would be straight up and down. 0 would be, you know, on the x-axis. And then it has a frequency and a dampening ratio. So this is meant to simulate like kind of a springy wheel. We want this to be a little bit more rigid. Well, I can show you what it looks like if it's not, but it's going to basically make it really bouncy. So let's go ahead and hit play, and you can see the objects. You can see the wheels almost completely pass through the object itself. And so that's a bit too springy for my taste. Now, if this was a much bigger object, then, you know, these values might make sense. But since we have a little tiny object, I'm going to go ahead and change these. You know, my dampening ratio, I'm going to make it very stiff to like 0.95, and my frequency, I'm going to make it very high so that it oscillates really quickly and gets to its location. And same thing here. And then this, all right, will give us a stiff suspension for our object. Now these objects themselves, you know, we don't want them passing through the object, the parent object. And so we want to make sure that we have it set to have collisions, okay, with the front wheel. Back wheel should not have collisions with the object, or should have collisions with the object itself, to make sure they can't pass through. We don't want our wheels to pass up and through it. Now it's different if you have a sprite that has, you know, if we look at our scene here, and let's get to our car. You know, if your scene is such that like your sprite is passing behind this object, then you don't want collisions enabled. Here I'm just trying to make sure that my wheels don't pass through the top of my car. So so they stay on one side. So that's basically it. But in the case that you had a different sprite, again, you might turn that off so that you don't have to worry about it. Okay. So we have the beginning of a car. Now what we want to do is add some motion to the wheels. So if we go to the back wheel and the front wheel, we can take a look at how to set this up with the wheel joint. So in this case, what we want to do is say use motor. So I'm going to just set up one motor on the back wheel, assuming this is a rear wheel drive vehicle. So we'll say use motor, and then we can set the motor speed to be whatever we would like. So maybe the motor speed is going to be, you know, 200. Okay. And then we'll just hit play. And what you'll see is that this motor is going to be rotating. Now, my objects are really bouncy, so I could probably turn that off on the ground. But you can see that the back wheel is now rotating, so it's being forced. And let me come into the scene here again. And we'll zoom in, and we can just sort of see what's happening. So this is being forced to rotate, and then this front wheel is not rotating at all, probably because of friction between these two objects. So we get that sort of motor effect that we're expecting. This is just forcing a continuous rotation to it. Now, you could, of course, do this through a script. So you don't have to turn on the motor feature. But if you had something that you wanted to always be going, you might as well do it so you don't have to write the script code for it. So let's go back and set a few more settings on this object. Zoom in again. And this time we're going to take it and we're going to just drag it over here so that it can drive on top of our bridge that we used before. And now I'm going to set up front wheel driving also. And I decided, you know, I'm going to turn off my collision because I think that's causing friction with my cart and I don't want that to happen. And I'll take my front wheel and I will also say use motor and I'll set the speed to 200. This is basically, if you look here, the number of meters per second, right, that the angular motor is going to apply. And so we can hit play now. Oops, we missed we missed the thing. So let's, because I forgot about the rotation and the bridge movement. So let's just bring it a little bit over here. This way it doesn't drop too far. And now we can see that both motors are turning. They're working their way up to get over. And it looks like we're stuck. So let's increase our motor speed a little bit to something like 500. There we go. Hit play. And now we can watch our little motor spin. And we can see there's definitely more force here, enough to get it over. Very kindly fell back on its wheels for us. Now that's the kind of thing that, like, if you're making a game, you'd really want your script to, you know, limit the angle, the rotation of the parent, right? You don't want your cars to constantly be falling on their back. And so you might limit, for gameplay purposes, how much it can actually rotate so that you're always landing somehow on, you know, basically the wheels in some way, so that you don't have to worry about, you know, that sort of misbehavior and then the player's stuck. Now, unless you're really trying to do some kind of simulation, like where you're trying to jump over a ramp or something like that, where you want it to really, you know, possibly land on its you know, top, and in that case you would, you know, make the car be destroyed or something to that effect. But generally, you know, you're going to do all that in the scripts, because if you just limit, if I were to come up to my car or my cart and I said, like, you know, don't allow it to rotate by going to my rigid body and saying freeze rotation on X, I mean, that's fine and all. So you can see what happens with that, right? But then I get no angular rotation ever, right? So it doesn't matter how I set my object here, it's never going to rotate, and that's probably not what you want. That is kind of weird behavior, but again, depending on your game, there might be some reason to do that. So as we can see, you know, the wheels continue to turn, they continue to go with the motor, and really the thing that you need to check when you're setting these up are, you know, how rigid, or what is the frequency of my spring. This sets up the spring settings for it. Which angle should this be? So if your car, you know, if your game is going up and down the y-axis, then you're going to need to change that. And then the motor speed, or using the motor, this all depends on if you want the wheels to turn automatically for you, or if you're going to do it through a script. And so that's really the basics of the wheel. There's not much other things to be that are complicated about it. Oh yeah, one last thing. The anchor is really the main issue you're going to run into, where the anchor might be in a weird position. And if you do change that anchor into some weird position, you get really strange looking behavior like this, where your wheel's connected off in some distant position on the object itself. So hopefully that clarifies how wheels work, and I will see you in the next video.